any detecting system, such as a radar receiver or your domestic radio or television, always is a question of separating the signal from the noise. The signal always has some randomness to it, as you might call it static in the old days, or flashes on the screen of your television set. And it's always there. And sooner or later you have to make a decision as to which change of electrical activity is random or genuine signal. And this decision has to be made either by a computer, which it can be done, or by the brain. And the signal-to-noise ratio, as it's called, is critically important. I don't think that Helmholtz thought much about noise, actually. I think that was a rather later idea. But he was very well aware that a given retinal image could represent umpteen different kinds of objects. He was completely aware of that. And he actually talks about looking at a room in dusk without too much light around the place, and it might be a square room or it might be a funny shaped room, giving the same image in the eye. In other words, he knew about ambiguity. And it was that I think he was concerned about, that you make a guess or an inference as to the shape of the room from knowledge of rooms and from rules such as perspective and so on. And that is how, in modern, rather nasty terminology, you disambiguate the image. That is, you settle for one bet as to what is actually out there from an image that might represent umpteen different kinds of objects. It might be big, it might be small, it might be parallel, it might be converging lines, sort of thing. And he had that idea. And his idea was that you infer from rule and from knowledge of objects. But this is actually a sort of inductive inference. It's not solid deductive inference. It involves a lot of guessing, in terms of probabilities of these kinds of shapes a room is likely to be, for example.